My name's Rob Miller. I've worked for probably half the people in the room at some point in time or another, or some way or another. Southeastern Regional Sales Manager for Iris, based out of Bradenton, Florida. We are the world's only industrial-grade infrared window manufacturer. We don't sell cameras. We don't sell ultrasound equipment. We basically are a technology enabler. Started out as a Navy nuke. Been in the maintenance and reliability field for about 25 years. When you're looking at doing any business program, it all comes down to dollars and cents. Is it a good business process? The greatest technology in the world, if it sits on a shelf somewhere, doesn't really add value. And even if a program is enacted, it's not going to live and grow. It becomes a paper exercise. So safe electrical maintenance makes good business sense. Are you speaking the right language? If you look at it, a lot of people do criticality assessments. They look at different pieces of equipment and normally rotating equipment. Do we do vibration analysis? Do we do ultrasound? Do we do all the different technologies? But without electricity, nothing rotates. So all the money you spend on all the technologies is really lost. That's why you'll see many of the papers here this week have been about electrical. Because in the past, if you flip the light switch on, you don't worry about the wiring in your house. Same thing in an industrial environment. As long as the power is stable, nobody really pays attention to all that electrical gear. Something that's changing. What are the consequences of an unplanned mishap? We were talking about transformers and what the lead time is. And back in the day, it was nothing. GE kept a whole pile of them, and you made a phone call, and it'd be there in 2 days. Somebody drive it down to you. The last one that I had any dealings with, it was a 52-week lead time for a new transformer. We had to make it a full year before we could get a new transformer built. And how do you plan to get results in improving reliability? So every business, regardless of industry, you convert electricity into wealth. You know, it goes directly to the bottom line. Where do they make aluminum? It's not where they dig the aluminum out of the ground. It's how close can you get to an electrical source, because that's the cost. Without electrical power, nothing's produced. Any disruption in your distribution has a huge impact on the bottom line, which is when you speak in those terms, the money becomes much easier to get to buy the new technology enablers. And one thing that it makes it tough if you're not speaking the right language, and very easy if you are. If it's worth being in business, it's worth putting the money into it to maintain the production. Where he's saying, you know, we want to get the maximum life out of our bearings. You know, so we identify the defect and then we wait until it gets right to about where it's going to fail and then do the change out. If it's planned and it's scheduled and it's ready to go, should something happen, that's one thing. If it's we want to limp along until we get to that fix, that's another thing. And you know, if it's a $10,000 bearing and they're saying, well, we want to get our money's worth out of it, identify the root cause and get the money out of it. Change it once, don't change it repeatedly. Consequences. How long does it take to recover from something like this? The example that I usually throw up is Apple, Foxconn. They had an explosion. It killed a couple of workers, and they stopped production of the iPad 2. Apple did the right thing. They shut down production until they could identify the cause of the explosion. How many people here own any tablet other than an iPad 2, right? If one had been available for a cheap price, would you have bought the iPad? Probably. Yeah, what was the market share cost to them? Now Apple's, you know, huge, and they absorbed it and they spun it and made it a good thing, but they literally stopped production for a month until they could identify the cause of that accident. What would it do to your facility if you had to stop production for a month? How many customers are you going to lose? How many orders did you not fill? How many of those orders are going to go to your competition? And that's built into why we do electrical maintenance and what is the cost long term to recover from a fire, an arc flash incident. Consequences. Are you using your energy wisely? Are you losing power? On-time delivery. If you shut down an automotive plant, BMW is the one that I've worked at in the past, it was $12,000 a minute. If you stopped production on that line, it was $12,000 a minute. What does it cost to buy a $15,000 and start doing all the things that we're here talking about? Environmental releases. What if it's your wastewater system? And nobody likes to talk about wastewater, but if you can't do anything with the waste that's being produced, you have a certain amount of storage capacity and then you stop production. If that power is not there to process that waste, you're done, you know. Employee safety is obvious. You know, you don't want to hurt your people. You want them to come in and feel safe, leave at the beginning, leave at the end of the day the way they came in at the beginning. Happy workers make for better workers, more efficient workers. Raw material utilization. If you've got lines that are up and down, it costs. If you're printing aluminum printing plates and you stop the line, how much aluminum is in the line that then is scrapped? You know, that thing, that one little hiccup on a variable speed drive, what does it cost you? First pass yield, along the same lines. If you're making poor quality product, you either have to QA and find it before it gets to your customers or make it good for the customers when they get it at the end. So it all depends on reliable, incident-free operation of your electrical distribution system. A few facts. 1,400 insured fire losses cost about $1 billion between 92 and 2001. And these statistics are skewed a little bit in that lots of companies don't like to say, well, we don't take care of our electrical system and that's why we weren't able to produce your product. It's always somebody else's fault. It's always somebody else's problem. Power disruption costs U.S. businesses $80 billion a year when you look at it that way. And 50% of the electrical deaths and severe injuries are associated with routine maintenance and repair. That's huge. 50% of the people that are killed, it's because of something that was routine. They've done it 100 times before. And, well, yeah, all that arc flash stuff, I'm not really interested in it. Neither was the guy before you that was the last one. A few more facts. And I'm going to turn around for this one because I don't know these numbers. I'll just tell you. Loose connections, loose parts account for 30% of electrical failures. That loose connection can be found arcing, tracking, corona, infrared cameras, all the things that we're here talking about. If you went in and said, I can take care of 30% of the lost production in a facility, it's real easy to justify the cost of the technology. Moisture, another 17%, and that again goes to proper maintenance of the asset. Are you maintaining it the way the OEM says that you should? Yes, OEMs tend to err on the side of caution, and you take that OEM recommendation for maintenance, and sometimes you do exactly what they say during the warranty period, and then as time goes on and it's stable and it doesn't change, you back off a little bit. But honestly, moisture getting in there, there's really no excuse. If you're getting moisture inside your electrical distribution system, look at the root cause. Is it the cabinet's fault or is it the lack of maintenance of that cabinet? Line disturbances other than lightning, that's where big loads, transients cause things to brown out, black out. Defective or inadequate insulation. There again, was it an installation issue? Was it a breakdown over time of the insulation? More often than not, it's lack of maintenance. Lightning, nothing much we can do about that. Better grounding. Foreign objects and short circuiting, 7%. So that's somebody dropped a wrench, a squirrel got in the cabinet during the night. Collisions, that's somebody on a forklift just not paying attention to what they're doing. And the generics, overloading, inadequate capacity. Are you running it at the level that it's supposed to be, or is it consistently overloaded? And accumulating the dust, dirt, and oil goes to, again, maintenance. And then everything else all lumped together is 8%. And these are actually insurance claims from Hartford Steam Boiler. Electrical reliability involves paying attention to three things: the equipment, the people, and the systems. And by systems, it's on the slide here, it's control, protection, emergency, but it also is the management system. Many of the failures that are out there are not because the technician didn't want to do his job. It's because the technician couldn't do his job because there was a staffing issue, or there was a just-in-time supply system, or there was a big order that we had to get out. People, it's about managers, technicians, operators. Getting the operators involved, getting that buy-in makes a big difference in the end result. And equipment, everybody's got equipment. It doesn't matter whether it's a swimming pool pump, 1/4 horsepower, or a 4,000 horsepower 4160 volt motor. If it's worth installing and it's worth spending the money for it, it's worth maintaining. So in this plant, they were looking at their reliability, switchgear incidents. They came through and they started doing some recommendations as far as these are the things that we need to be doing, and you can see where the number of incidents went way down. And then creating an extraordinary collaboration. Basically, a maintenance guy going and saying, this is what we need to do, this is what we need to do, this is what we need to do, and it sort of falls on deaf ears. If I go in as a technician and I start talking about acceleration or dB levels or, you know, focal point arrays for infrared cameras, the managers kind of tune out. It's not their core competency, and they really don't care. Their job is to produce. Operations wants to produce. Management is gauged on how they produce. Supply and procurement, their job is to procure. How your maintenance affects them makes a big difference. And so speaking the right language really enables you to get the point across, but you've got to put it in the right terminology for them to understand it. And in a lot of cases, less is more. If you're going to go in and you're going to beat them up with statistics, they're going to tune out. They're going to wait for the last 5 minutes of it, and then, you know, what you said at the end is what they're going to believe. My boss, if you take and you want to send him something and you don't want him to read it, put it in a big email and put it near the bottom, because he never gets that far. And so you can buy things you want by just adding a lot of verbiage. The technicians, you need the technical experts, most of the people in here. If you're going to figure out how to do something, you need the people with the actual skills involved in the process. Top-down push because a salesman told them this is the newest and greatest, and they bought because it was the cheapest. And then you put the tools in the hands of the technician and they go, man, this thing is junk. And they don't get it. You're not going to get that. And then also the safety professionals. If safety buys into what you're doing, there's a whole nother pot of money to draw out of to buy things, but it also gets them involved and they understand what it is you're doing. When you come to them and say, look, we've got to fix this fan and we need to do it right now, and they go, oh, well, you know, we have to do this and we have to do this and we have to do this. If you don't get buy-in from everybody involved, you're a loud drum and nobody pays attention, and eventually you tune it out. Some of the tools and resources for electrical maintenance, you got IEEE, NFPA 70B, NETA 70E, and then PAS 55. And the reason I put all of these on this slide is basically we're stuck in our own geography where we're looking at it from our point of view. And there's things that PAS 55 does that make a lot of sense, but it's not mandatory for companies in the US to do. But just because nobody's holding you accountable for it doesn't mean you can get the value from it. Knowing that you're a multinational corporation and you're worldwide, you want to pick and you have to be compliant with all of the different standards. But picking and choosing things from another standard that make more sense are good business. And so they're available, they're out there. Everybody should have a copy of at least 4 of these right off the bat. And there are much safer technologies that can be employed. You got remote racking, you got, well, most of them are across the other side of this wall. You got infrared, you got ultrasound, you got PDMA testers. And looking at them, they're a tool. The results you garner from that tool can either work or not work. And so if you are using the tool correctly, our job as technicians is to find the defect and report it to management. And then management makes a decision. We're going to let it run until it fails, or we're going to jump on it right now. We're going to plan and schedule the job. But getting them involved makes sense, and using newer tools. I'm a tech guy. I like the newest and the latest and the greatest, but it's not always the right way to go. I mean, there have been facilities I've been to, and where's Doug? He's not going to throw anything at me. It was a paper mill, a little teeny tiny paper mill. They recycled cardboard and made the little drink holders for McDonald's. And for them, a squirt bottle with soap and water with an operator looking for air leaks worked all day long. They were never going to produce enough to purchase a $15,000 system. But soap and water worked all day long, and they fixed it as they went. And so there are ways of doing things safer. There are ways of doing things less expensively. But if your efficiency of your inspections makes sense to purchase all of the different products, it's worth doing. Implementing proven strategies to maximize safety and compliance with standards. There's different types of maintenance you can perform. It goes for mechanical as well as electrical. You're looking at corrective maintenance, preventative maintenance, functional test, your annual inspection. Do you test your relays? How often do you do the less routine maintenance tasks for your electrical distribution system. As you're planning your maintenance program, planning those in makes sense. You don't want to have them sprung on you at the last minute. You want to build them in. Predictive maintenance and then proactive maintenance. Corrective maintenance, it's unplanned maintenance. When it breaks, we'll jump, we'll fix it. We keep a whole pile of spare parts. We don't really address the root cause, we change parts. There's no thought involved in it, it's a part changing. And some plants that makes sense. In others, it's absolutely wasteful. Preventative maintenance, well, we figured out that the bearings on this conveyor fail once every year and a half, so every year and 5 months we're going to change all the bearings. That way we know we're good. It involves a lot of parts that aren't very bad that get changed out just because that's the way the program is identified. It can be either calendar or time-based, and it involves subsequent repair work. If there's been other damage that was done because it ran too close to failure, then you schedule that and you put it further down the road. Functional test, things that don't necessarily get used during normal operation. The overload that trips out a 2,000 amp breaker, you don't really want to functionally test in production. But there's plenty of people out there that will come and do that. And so you do it on a regular basis. When it's not actually in production, you can simulate that. Usually done during an outage, which makes it hot and sweaty and it tends to be expensive. And you get a big investment in the equipment and the training, or in a third-party contractor that comes out and do it, and they involve the training and the people and personnel, and so you pay a premium for that. Predictive maintenance, it can be done periodically, it can be done continuously, it depends on the system. There's online monitoring systems, there's manual inspections that are done. There again, significant investment in personnel, equipment, and training, unless you use an outside contractor. You're only as good as the system that's implemented in. When we were talking earlier about the international paper, they do a pretty good job of identifying the defects, but he said one point that really made sense was, when we identify it, they fix it. There's plenty of places where I've worked where I identified a defect, and I identified a defect, and I identified the same defect, and it ran to failure anyway. They were spending the money and never actually getting the value out of the program. And your return on investment is really dependent upon the actions taken once the defects are identified and presented to management. There are plenty of cases where it makes good business sense to run something to failure. There's also plenty of business cases where it wasn't communicated well and something runs to failure when it didn't have to. And then proactive maintenance focuses on eliminating the root cause of the defect, looks at machine parameters. Is it design? Is it operation? Is it maintenance? How do you really get at the root cause? And does the root cause actually involve an equipment change, a personnel change, a management change? If the root cause of the problem is operations wouldn't give us the equipment, then operations has to change, maintenance doesn't. But sometimes maintenance needs to change the way they ask. Or has it put in the CMMS system as a routine? Is it put in as a fire? Are you fighting fires, or are you changing the culture? And then maintaining electrical assets. And it's got the little NFPA logo here because they really have a great system as far as the NFPA 70 standards. How do you determine your plant needs to be performed to ensure electrical assets are safe and reliable? Start with 70B and 70E. NFPA 70 is the National Electric Code, and it details the installation parameters. How many pieces of, what size and how many conductors go in a piece of conduit. It makes sure that you're at least installed safely. 70B addresses the maintenance, the operation and maintenance of the equipment, and then 70E and how to do that maintenance safely. So using 70B, it really doesn't take into account how is your equipment operated. Everybody with every plant, there's a different signature. There's a different operation mode. Is it variable speed? Is it continuous? Or is the competency of your maintenance personnel? Are they trained? And the failure modes of your assets and your environment or culture. So, although electrical components may be exactly the same brand, model, and type, they operate in different environments. The context can differ, and it changes the maintenance requirements. If you're operating in a miserable, dusty, extreme temperature change, it changes how you maintain that asset as well as the criticality. A truly complete maintenance strategy involves considering the context and criticality of the asset as well as the type and model. Here again, electrical equipment can be exposed to temperature extremes, moisture, airborne debris, corrosive chemicals, as well as a buildup of contaminants causing overheating. How do we maintain it? Do we clean it? How do we operate it? Is it in an outside environment, inside environment? Is it corrosive? All those things need to play into your maintenance strategy. Is your equipment really that different? You know, you might have 4,000 motors in one area, but if 3,600 of them are exactly the same, you got a lot of your work done for you once you figure out one of them. Determining what's really different about them at the onset of a program allows you to copy and paste, for lack of a better term. Are the operating parameters manually adjusted or automatically controlled? Is there an operator on third shift? Everything that ever breaks happens on third shift. As a guy in a plant, everything breaks on third shift, and nobody knows why. We didn't do anything wrong, boss. And well, how are you operating it? Are you loading it up so you don't have to walk out there as often? Are you operating outside of the pressure parameters? Or is a PLC keeping track of it? And are the instruments, feedbacks, and controls really calibrated or maintained? It's great to maintain your electrical distribution, but if the controls that are running it aren't maintained as well, it's just as likely to fail. So, are your technicians adequately trained? How many of you, and we're going to ask this to get everybody involved for a minute, how many of you received most of your experience on the job? All right, how many had some formal training in the past? Completed an apprenticeship? Went to a technical school? Everybody here has been to a UE school, come on. And are qual standards in place and documented? Do you have a written practice? Right? You can be certified vendor-specific ultrasound level 1, but what does your company do with that? They accept ultrasound certificate and you're good to go? Or do they actually take the time to develop a written practice and say, as a certified ultrasound level 1 personnel, what does that mean you need to do? Not how do you do what your job is, but what do you need to do in order to be certified? Really, that makes a big difference. Or were you trained by external contractors? Sorry, there's the UE one. Everybody's hand should go up, right? And reliability-centered maintenance takes into consideration the environment, the context, the experience or inexperience of the people, and the performance standards that must be maintained to ensure safe, reliable assets. 7 steps of reliability-centered maintenance. You got functions. Describe the main and support functions as well as performance standards that we need to maintain. Identify what we expect out of the program. It's one thing to go and willy-nilly just check everything, how much your time is wasted. Do it on the things that make sense first. What are the functional failures? Describe the inability to maintain the performance standards. Defining the performance standards makes a huge difference sometimes. What is your electrical distribution system supposed to do? Well, it provides power. Yeah, but how? Well, it's got to provide power within this voltage range and within this load range and within this, defining that sometimes changes the thought process and gets people a little bit more involved. And the failure modes, what happens? If we blow up that transformer, what happens? Describing what's going to happen and how it's going to fail makes a big difference. And thinking about that at the onset of a program allows you to do some planning and scheduling. Do we need to carry that as a spare part? Do we need to apply a technology to it? How something fails is as many times as important as how it runs. The failure effects. Again, what happens when each different failure mode occurs? Defining how that happens and how you recover from that is a big part in setting up a program. What are the events that lead to that failure? What's the first sign? Where do we catch it on the P to F curve? Is ultrasound going to pick it up first? Is oil analysis going to pick it up first? Is vibration going to pick it up first? Identifying that gives you a clue as to what technology to apply first. If you're going off a bucket list and you go, well, we've got this much money in the pot and we want to get the most bang for our buck, knowing that makes a big difference. So setting up your maintenance strategy around that just makes good sense. And the failure consequences. How does the impact affect your business? Is it environmental health and safety? Is it operational? Is it purchasing? Did we have to FedEx something in from Germany because it's a one-of-a-kind part and we had to buy one used off of eBay? Or is it you run down to Home Depot and pick one up? And you'll get both. You really will. Developing the maintenance tasks. Going through and identifying all the tasks that asset 1, 2, 3 needs What's right? What should really be performed to that asset? Developing that list and getting all those people involved in it makes sense. And reduce the consequences. What can be done to reduce the consequences of failure? Do we need a second pump in reserve? Do we need 3 pumps and we put them on a VFD and we get reliable, they ramp up when one of them goes to fail? How do you maintain the business process, the production, with as little consequence to a failure? You don't ever want a failure, right? Nobody ever wants to fail. It's the way to do things. But stuff happens. Planning that failure mode and reducing the consequences of it makes really good sense. Failure modes, effects, and criticality analysis. In 70B, it states, part of an effective RCM program is to determine the failure modes and conduct a criticality analysis of all systems. Determine the risk priority based on the product of the severity level of a component, failure occurrence level, and the detection level. Basically, figure out what's going to go wrong. How often is it going to go wrong? What are we going to do if it goes wrong? And how are we going to fix it? Define all that. My boss loves this saying, and it's one that I repeat all the time. You don't know what you don't know. If you haven't dug into the process and you haven't done your homework on the front side, you don't know. And so, when was the last time your breakers were relay tested? Well, I don't know. And analyzing every failure is critical to building world-class maintenance. Just because something fails doesn't mean we slapped a new part on it and we go on down the road. Figure out why it failed. And every failure mode that you eliminate and correct is one that should never happen again. So if there's 13 ways asset 1, 2, 3 can fail, and one of them fails, figure out why and eliminate that cause. Now there's only 12 ways it can fail. And over time, you start here's our line in the sand, and from here on out, every failure we have is going to be investigated and the root cause identified. And maybe you don't completely eliminate that root cause, but you learn what the effects are leading up to it. How do we minimize it? How do we plan it into the system? And you got to learn from your failures as well as your successes. Everybody will tell you we had 2% downtime, right? Oh, 2% downtime. Those darn maintenance guys, they never say that means there's 98% uptime and availability. OE works both ways. So identifying the reason that it failed sometimes doesn't point at a maintenance guy. It points at an operational context. It points at a purchasing. We said we wanted the 15,000, and then you guys went out and bought us this Radio Shack kit that was put together and looks like a brick. You know, those things happen. When a purchasing guy gets involved, sometimes they buy the lowest bid. And being able to identify why something failed makes a difference. Doing the root cause analysis. Evidence-driven process, at a minimum, should uncover the underlying truths about the past adverse events, exposing opportunities for making lasting improvements. Everybody in the room that ever went to a root cause analysis and thought, boy, they're going to hang me from it. I mean, I have done hundreds of them. A root cause analysis is not about pointing fingers. It's not about identifying who's at fault. If when people would come in to do an RCA, it would say, unless you did something grossly negligent or dumped a toolbox in the gearbox, nobody's to blame for this. You would get to the actual root cause. Everybody's trying to cover their own tail, and so it was never my fault. I mean, I've done hundreds of them. It was never my fault. You know, when your job's on the line, it's self-preservation. But really, that doesn't get to the root cause. And it depends on the facilitator of the root cause. But there's a lot of different approaches to it. Asking why 5 times works great. You don't have to cater in lunch. You don't need 8 hours of people talking about it. Why'd that fail? Well, because we didn't grease it. Why didn't you grease it? Well, we were working on this over here. Why were you doing that? Because you told me to? Okay, you got to the root cause, and it wasn't about beating up a lube guy that didn't do his job. It was about too much time, or too many tasks, not enough time. And so maybe you hire another vibe guy. Maybe you hire another lube guy. If you get to the root cause of the problem, it makes a difference. And you can do fish bones, you can do a lot of different things. Failure reporting analysis and corrective actions provide a process by which failures can be reported in a timely manner, analyzed, and a corrective action put into place. Lots of people do root cause analysis and they figure out this is why we didn't get to it. But there's no action items from it. So, yep, we identified the root cause. We're done. Check mark in the box. That's what corporate says we have to do. But what do you do with that data once you've gathered it? And so the guy that identified the problem, hey, I went to start the pump and it didn't work, he doesn't ever see anything. So does he give you the information the next time? Maybe. The third time, he's got to be really dedicated. The fourth time, he's going to walk right on past it. And if you don't get the buy-in from the guys on the plant floor, it's never going to happen. And so how you respond to a root cause analysis, you don't necessarily have to dig in miles deep. Sometimes it's real easy. Sometimes it's a coffee break, smoke break, whatever it is, getting to small victories a little bit at a time. If you're looking at an RCM analysis of, you got your utility feed, you got your site transformer, it comes down to a switch gear, feeds a motor control center and goes out to a disconnects, maybe another transformer to step it down to an actual load. And so identify each one of them. What are our potential defects with the 3-section MCC? Okay, these are the things we need to do. An electrical distribution system is sometimes looked at as one big asset in plenty of CMMS systems. Or maybe the disconnect is tied to the actual rotating equipment. And so does it ever get any real bang for the buck? Is it really tracked the money that's spent on the disconnect? No, it's ignored. It's a light switch. You turn it on and it works, you forget about it. But if that disconnect doesn't work, there's no production. It's just as valid. The electrical system can either be looked at as one entire piece of equipment. In my view, you break it down and you identify the bottlenecks, so to speak, in the process. So you look at each different one. We're going to look at the switchgear. How many different breakers are there? What do they feed? What do they affect? There's miles and miles and miles of wiring in most industrial applications. And sometimes the little bitty one that goes to a PLC that controls pressure on this line shuts down an entire plant. It's a $2 fix. It's a $2 billion plant sitting there not making product because it was something that wasn't important. It wasn't included in a maintenance system. So identifying what you have and figuring out a way of dividing it that makes sense for your organization, it's not spelled out in any of the books. Some of it is got to be custom tailored, but taking what I call 30,000 foot approach and going, okay, this process has to run or we don't make money. Well, what does that process depend on? And when you look in a lot of the little software programs, excuse me, and well, Windows. Everybody that's ever run Windows, if you go on the management console on the back, it tells you that this process depends on this process and this process and this process. We don't any of us pay attention to them because that's what we pay Microsoft for, which we don't like, but it's part of it. So if your process in the back that runs part of your system isn't running, it's just as important and just as critical as your A-level assets or your B-level assets. Some of the things that are way down there as far as criticality goes carry a lot of the load of the plant. If you're looking at what's the function of a 480 volt switchgear, now you got to supply 480 volt three-phase electrical power while meeting all power quality, health, safety, and environmental standards. That's one little sentence that really speaks a lot. What does it do? Well, it makes power. As long as the light switch goes on, it makes power. But it makes power in a quality way. We don't hurt anybody. We don't have any accidents. We don't have any downtime. And so what's a functional failure? Well, it's still providing power, but the voltage is out of range. Or it's overloaded because we've got something else running. Failure modes. The door gaskets leak due to embrittlement. Wiring fails due to loose connections. Bus bar control wiring or terminal connection fails due to insulation breakdown. Fuse clips loose due to physical damage. Did they get annealed and get hot and now they don't work? That still looks good. You put a fuse in there and it holds it. You look at it with an infrared camera and, oh, it's hot. And so you put in a work order. Clean the fuse connections. And they go in and they clean them. Well, do they spring? Makes a difference. It looks good until you check it with a camera. Incorrect replacement. Variable settings on overloads. Prevents a safety trip in the event of an overcurrent condition. That happens every day. Every single day, somebody goes to their purchasing and say, we need a 200 amp breaker. We want a square D model MC309. And the purchasing agent gets on the internet and he goes, 200 amp breaker, lowest common price. Well, it'll fit and somebody goes back there and they start whittling away at connections so that they can make it fit into the enclosure. It'll work. It won't work well. And yeah, maybe it was 10% cheaper, but if you replace it every 6 months, you're now spending a lot of money. And so building that into your program makes sense. 70 is a perfect starting point for maintenance strategy, but it assumes several things. One, your equipment is properly designed and installed, and the equipment is operating correctly now. It's not overloaded. We're not limping along. Everything's perfect. 70B thinks everything is perfect. And so taking that and factoring into where you are to how you need to get to where you want to be, 70B is a great starting point, but you do have to apply it in the correct manner. And then safety standards and compliance, how do they coordinate with an electrical maintenance program? The world-class electrical safe work planning, right? That's a new one 70 came out with last August. Oh, you got to have an electrical work permit for everything. And the site superintendent, the number one man on the site, has to sign off for everything. That's great in theory. But what really happens? He eventually delegates, and then he delegates, and he delegates, and we go back to the way things always were. Nothing changes. Looking at the similarities to world-class maintenance programs. If you're looking at how do you do maintenance, well, the man at the top of the food chain, he doesn't sign off when you need to go do a PM. He has somebody that's competent. And that's the important key word, somebody that's competent. Site engineer, site superintendent, the guy out in the front office, he doesn't know what you're doing in an electrical situation. So he needs to have somebody that does. And so there's training involved. There's checks and balances involved. Somebody pencil whipping an electrical safe work permit it's going to happen. But if you're the guy that's putting your hands inside the electrical equipment, in the U.S., you kind of get away with that. If something happens, OSHA's going to come in and they're going to smack the company on the hand, and it's, man, sorry, Rob. I know you can't work, but we'll be around when you get better. In Canada, where's my Canadian guys? In Canada, if something happens, there was a Walmart. This happened just a while back. A guy running a floor buffer got electrocuted. A couple of burns. They wrote a big, huge fine for Walmart and a $10,000 fine for the manager of the Walmart location. And the guy that grabbed a hold of the buffer and knew that the cable was frayed, after he got out of the hospital, he had to write a check for not living up to the electrical safety program. Their 70 Z462, it's got teeth. It's not the company that's at fault. It's you, the guy that got electrocuted, and you, the guy that knew he shouldn't be doing it, and the company. And so OSHA really has that capability, and they have the ability to do it, but they don't yet. It's coming. So if you're looking at 70E and 462, they're the most practical application of these standards is assist in the reduction of workplace incidents from electrical energy. It's about safety, and it really applies cross borders. 70E or some variation thereof with a different title is going to roll out when it makes good sense in the U.S., and I'm not saying the U.S. because I'm partial to it, but if a national standards is going to come up with a 70E for the U.S., it's going to be applied. The applicable parts of it are going to be picked up because you see the value in it. Oh, we had this many incidents, and now we have this many incidents. That's money. And when money talks, people start making it happen elsewhere. So geographical lines really shouldn't affect your safety. Large emphasis is currently being put on the dangers of arc flash. Everybody needs an arc flash survey done, and they need it done last Tuesday at the latest. But you're twice as likely to get shocked, electrocuted, as you are to be involved in an arc incident. It's got the big push right now, and that's good for people that sell infrared windows, right? 70E is our friend, but really in an operational context, the ability to be electrocuted is a lot more likely to happen. PPE levels address this, but more subtle ways. You know, if you're looking at your HRC categories, somewhere in there in the footnote above or below it, it talks about voltage-rated gloves, and they're important. And how do you maintain the gloves? And how do you maintain the PPE? And how often do you purchase it? All that's in there. It's just not the main focus of it right now. Voltage-rated tools or gloves are considered second nature. Everybody's been using them forever, right? When I was in the Navy in the early 80s, we had HRC categories that we lived by. We're just now getting that in an industrial setting. You know, they make good business sense. The military did it because, well, the military's got this budget and it's, you know, spend it or lose it. But honestly, it's about operational readiness. At that level, it's important to be able to do your job. Your job involves defense of the country. Companies are figuring that out, and that operational readiness is just as important for a soybean plant or a tire manufacturer or somebody that makes pallets, and that they're seeing the value in that, and so it's rolling downhill. And it should be included in any program. What are the actual hazards faced with when performing maintenance? Department of Labor estimates that on average there are 9,600 serious electrical shock and burn injuries every year. That's a lot. 9,600 a year. That's 9,600 families and spouses and kids and people that were changed. Their entire life was changed because of something that they'd done 1,000,000 times. And it'll never happen to me. And so, one fatality a day due to electrocution. 80% of workers have worked live on sites that they identified as being a high or above average risk. How many of you guys have? I have. I can tell you right now, I've done things that were completely stupid in my past. I did it for the right reason. Oh, the company needed to do their thing. I lived to tell about it, and you know, God willing, I'll never do it again because I've seen the after effects of what happens. And so taking a minute to really think that into your electrical maintenance program is worthwhile. Do your managers really know and understand? When you come up and you start talking about dB levels and vibration levels or HRC categories, they tune out. And do they really know the potential risks? Speaking that language again, when you start identifying the potential problems, they listen a little bit more. And building in to the program what is expected at what level, make sure the technicians are doing what they're supposed to be doing, and post-job feedback and follow-up are part of any evolution. The fact that we built a procedure and we planned it and we scheduled it and we kitted it and we put it at the job site, that's great. But when we got there, we didn't have what we needed to do the job. If somebody doesn't tell somebody and it doesn't get put into some sort of feedback, you're going to always do it wrong. And so putting that in there makes a lot of sense. Who maintains the primary feeders supplying your plant? Well, it's just like the light switch. If when you go to work and if the power's coming in from the utility, we're good. Who maintains that? The utility? What kind of standards do they live up to? Believe it or not, their standards are a lot less restrictive as 70E. A lot of them aren't living up to 70E. They're starting to, a little bit, but they always got to buy because they were big business. And so the small guy starts first. What standards do they live up to? What safety standards? It's not going to say Walmart. Well, they're not going to say Manitoba Power and Light was to blame because something got electrocuted. It's going to say Walmart electrocuted a worker because of that. And so how they feed you power makes sense. And putting that in your plan gets somebody asking the right questions. 70E is really not the standard that tells you to use PPE. It says, energized electrical conductors and circuit parts to which an employee might be exposed should be put in an electrically safe work condition before an employee works within the limited approach boundary of these conductors or parts. It's not about PPE. It's all in there. There's charts and graphs and formulas and all the things you can do. But basically boil it down. Put it in a safe position before you put somebody close to it. If you can, don't open it up with it hot. If you're going to open it up hot, do a permit. You know, it's basically just spelling out what we should take for granted. And absolutely critical is the part electrical maintenance plays in the safety of workers. If you're putting your workers in an unsafe position, I've done it. Like I say, I've worked on stupid things in the past. I always thought I did it for the right reason because my boss wanted me to and I'm the go-to guy. But the boss should never put me in that position. And so don't put your management in that position. Lay it out for them. Arc flash hazard analysis, improper or inadequate maintenance can result in increased opening times of the overcurrent device, increasing the incident energy. If you go through and you do all the math, the time it takes for the overload device to trip is a direct multiplier. So looking at a survey by NETA in 2007 indicated that 22% of the service age breakers had some type of malfunction, and 10.5% of them did not operate at all. So because that breaker stays closed all the time and doesn't get exercised and doesn't get checked out, when it actually comes time for an overcurrent condition, it doesn't trip. So what did your time just happen? A 13 millisecond breaker just went 2 minutes while the conductors melted. That arc flash we did our calculated energy and it's supposed to be 13 milliseconds. It went on for 2 minutes. What is the value of the arc flash analysis at that point in time? How high should you set the bar for safety? Proactive maintenance recognizes and addresses situations to prevent them from ever becoming urgent problems or breakdowns. What are the moral, social, and economic costs? There's a lot of cost involved with any electrical injury. You got the actual person that's hurt, the production. There's a lot of different things. And poor maintenance activities is really costly. It's not a win-win-win, it's lose-lose-lose. So owners, managers, supervisors, and workers all pay some cost. Opportunities. Do your maintenance program or practices identify and prioritize equipment critical to electrical reliability? Does the design of new facilities incorporate application of PDM maintenance technologies? How many people have ever wanted to kill somebody that engineered something? Those damn engineers, if they ever had to maintain this, they wouldn't do it that way. Everybody does it. Well, whoever told the engineer that it didn't work? If you don't feed back to them, they're going to keep doing what they're doing. And how well have you integrated electrical power equipment into your business decisions, addressing maintenance management systems? Is the electrical system even involved in the CMMS? A lot of times, no. Is your approach to electrical maintenance aligned with your organization's dependence on uptime and reliability of critical electrical energy and control systems? Take it one bite at a time. Standards like 70E, 462, and 70B are there to help build the framework. Processes are time-consuming and require a disciplined and determined management team to ensure successful implementation. If management doesn't buy into it, they might let you buy the tool, but you'll never make the program work. 90% of RCM programs fail in the implementation phase. 90% of the programs fail in the implementation. You got the tools, you got the people, you got the training. Just go do it. Doesn't happen. Consider using outside resources to assist in getting your RCM team trained in the processes involved in setting up your electrical maintenance program. You don't have to be an expert on this. There's people that are. They're looking for work. They want to be your friend. They want to do a case study with you. They want you to tell your friends because they want the continued business. And create your own extraordinary collaboration. The rewards will benefit every area of your business, especially your bottom line. Anybody got any questions? Just come see me.